Welcome. This video will cover the parametric analysis in Classic and AEDT Icepak. Let's see how parametric setup is added in Classic Icepak. Here is the interface of Classic Icepak with a project. In the Project Manager window, expand Model and double-click on left fan. Go to the Properties tab of Fans dialog window and in the Fixed Flow for volumetric, enter $CFM. Press enter. In the parameter value dialog window, keep the initial value of CFM to 0 and click done. In the fans dialog window, click done. Click on run optimization icon and in the setup tab of the parameters and optimization dialog window, for trial type, select parametric trials. Go to design variables tab and for variable values, select in range. Enter start value as 1 and end value as 5 and increment of 1. Click apply. If base value is not set to 1, then it will show a warning stating 0 is not in the list of discrete values for CFM. Add it. Click no. The value should appear in the blank behind discrete values field. Go to the trials tab and make sure all trials are selected. Go back to the setup tab and in the advanced settings, set the number of concurrent to 5 so that 5 trials can run parallelly. Note that this will require enough licenses. Toggle off allow fast trials and click run to start the trials analysis. Once the analysis is done, close the solution residual window and in the parametric trials dialog window. All trials and their corresponding runtime can be seen. Click dismiss to close this window. Each trial result can be post-processed individually. Click on the Load Solution ID icon and in the Version Selection dialog window, select the desired trial ID and click OK. Now let's see how parametric setup is added in AEDT Icepak. Here is the interface of AEDT Icepak with a project. In the AEDT, there are two types of variables: project and design variable. Project variables can be assigned to any parameter value in an AEDT design with scope visible across different designs. Project variables must include a $sign as a prefix in the variable name. Design variables can be assigned to any parameter value in an AEDT design with scope local to the current design. In the Project Manager window, expand Thermal and double-click on Large Flash. In the General tab of Block Thermal Model dialog window, for total power, enter $Large Flash Power and press enter. In the Add Variable dialog window, keep everything to its default and click OK. Again, in the Project Manager window, double-click on Small Flash. In the General tab of Block Thermal Model dialog window, for total power, enter small flash power and press enter. In the Add Variable dialog window, keep everything to its default and click OK. In the Project Manager window, right-click on Optimetrics and select Add Parametric. In the Sweep Definitions tab of the Setup Sweep Analysis dialog window, click Add. In the Add or Edit Sweep dialog window, verify variable is $Large Flash Power and verify its nominal value is 1.25 watt. Keep linear step selected and enter start value as 1 watt, stop value as 1.5 watt with steps of 0.25 watt. Click Add. In the right side of this dialog window, variable and its parametric description can be seen. Click OK. Again, in the Sweep Definition tab of Setup Sweep Analysis dialog window, click Add. In the Add or Edit Sweep dialog window, change variable to small flash power and verify its nominal value is 0.5 watt. Keep linear step selected and enter start value as 0.1 watt, stop value as 0.9 watt with steps of 0.4 watt. Click Add. In the right side of the dialog window, variable and its parametric description can be seen. Click OK. Go to the Table tab and verify that there are 9 combinations of 2 parametric variations. Here, any variation can be deleted and a new variation can be added. Let's delete the 9th variation. Select it and click delete. Click on add to create a new variation, and for small flash power variable, change the value to 1 watt. Optometrics will use analysis setup settings. To verify it, go to General tab and make sure that setup 1 is included. Go to the Options tab and enable Save Fields and Mesh. It will enable the post-processing of the results. Click HPC and Analysis options to specify the cores to be used and trials to be run concurrently. Edit the configurations and specify tasks and cores to be 12, so 12 cores will be used in total. In the Job Distribution tab, switch the single level only to enable 2 level and change the number of distributed solutions at first level to be 3. In this case, 3 trials will run concurrently and 4 cores will be used for each trial. So a total of 3 times 4 of 12 cores will be used. Click OK to close all the dialog windows. To analyze the parametric setup, in the Project Manager window, expand Optometrics, right-click on Parametric Setup 1 and select Analyze. Expand the progress bar to see the progress of all the parametric trials.